Yeah, we all this thing, I swear. Let's go. I can't use that camera. Really? The base is back. I just got it back when I'm back. Eh? Can't I use, you see webcam? Can't you use back? Bro. I don't know why I cannot just use this thing. Font is far better, bro. Yeah, I should to rotate my phone. I want to rotate like this. So as you going to enter, this one tab you stand straight. Jesus. Oh, I miss a glass of our. Abi? Yes, then there's the other way too. Because I'm tired of self-stimulation. Okay, perfect. So to it. So I'm not trying to for sure. Oh, better. Yes. Okay. So I'm getting the hinge of it. Alright.
it.
Hello. All right. Okay. Good evening, everybody. Good evening, everybody. If you can hear me, just like type something on the chat, so I can hear me. Okay. Can you type something on the chat? All right. So we start now. We start now. So you are welcome to Success Catalyst 2.0. So big yesterday, although it was not held on live, right? Like it was held on Telegram yesterday, right? So I was able to successfully establish the basics of iPhone and everything about it, or really sure how I'm proceed today. But this is the thing we have on board. So today, what are we looking at today? What supposed to expect today? All right. Welcome to my YouTube channel. All right. So this is success capitalism. So we are putting this in a bit to try and see how we can um, help or aid UTM students that is having their JAM examination next month and next week. All right. In order to see how we can make up for the incompetent of UTM students. All right. So today is the day two. I'm looking at um, clean or four major aspects of chemistry. And today's chemistry, we are looking at chemistry, right? It's already on the board. And we'll be looking at quantitative analysis of chemistry, that's supplementary, right? So looking at some questions. Then we're also looking at redox reaction and a bit of hyper nomenclature today on this life. All right. So we'll be needing some alcohols and some other compounds. All right, guys. So let's proceed. So, so I don't know if anyone can hear me, then you can type on the lecture so that I know that you're following. Right. So basically, this is our question today. So we'll be starting with quantitative analysis of chemistry, stoichiometry. So we have the first question on the board. First question on the board. Now this is the approach. We want to try and exhaust about 30 questions, right? 30 to 35 questions or 40 questions today, different aspects then before in all the various aspects, accumulating 10 to 35 questions today. All right. So we'll be proceeding immediately. Now, the first question says, how many moles of calcium trioxocarbon 4 are there in 2.5 grams of compound? Now, this is for what? Mole concept. This is under mole concept. Right? Now, you agree with me that the molar mass of a particular compound, right? Now, you agree with me that whenever we are calculating molar mass, what we are doing is that we are actually adding individual atomic masses of this element together in the compound. So if I say the molar mass of this compound, I'm therefore saying that this is the weight in gram, right? In gram of one of that compound. That's what I'm saying by the molar mass of that compound. So this is the weight in gram of that compound in one mole. So that's why whenever you are calculating for molar mass, the unit you use for gram per mole. That means that is the mass, right, in grams in one mole of that compound. So one mole of the compound is just like a unit of that compound, small unit of that compound. Like when you want to look at so that's that. So now the asking us from how many moles of calcium carbonate 4 are there in 2.5 grams of what? Calcium carbonate 4. Now this question is very easy. It's very simple. Now to solve this question, all right, to solve this question, it's very easy. Now use the formula. There's one mole concept formula that connects your number of moles to molar mass and atomic mass is written as one composite as well as mass. Now in this question, I ask number of moles, kilometers, yeah, number of moles equals what? Mass or molar mass. Now this question is asking us our number of moles. By saying asking us by inquiring for our number of moles, then this is the formula we are going to use. So mass that is made is 2.5, right? 2.5 mass was in. Right? And molar mass, what we are going to do is test our molar mass, we are going to get the individual elements of that is we are going to add, we are going to submit, or we are going to add
the individual masses of this element together to get our molar mass. So to do that, molar mass of calcium trioxycarbonate 4 becomes atomic mass of calcium is 20, right? So that's 20 to get this, plus carbon is 12. The atomic mass unit of carbon is 12, plus oxygen is what 16. Plus how many moles of oxygen can we see? Can see 3 moles there. So we bracket it 16 times. Right? So that 3 plus 12 is what 32. 16 times 3 is what 8. So 32 plus 40, 16 times 6 is 48. 32 plus 48 will give us what 100. Right? So 100 gram per what per mole. Right? 100 gram per mole. Right? So since this is our so since we got 100 gram per mole, we can now solve. So our number of moles, we have our mass, our molar mass now. So our number of moles becomes what mass, which is 2.5 gram divided by what molar mass, which is what 100. Right? By doing that, this is basic what arithmetic. So we just move what 2 times 1, 2. So this now becomes what 0 point, right? 0.25 moles, right? 2.05. So best option is what 0.05 mole. Option, right? So I believe you want to this. It's very easy. Right? It's very easy. Okay. All right. So now this is for the first question. So the second question will move immediately. All right. So answer is what 0.025 was mole. That is the number of moles that is found in what one in 2.5 grams of calcium carbonate 4. And then we continue. Let's proceed. For the second question, question two. Question two says the number of hydrogen ions. Now, take note, in chemistry, whenever you see that a particular what atom has a charge, right? That atom is no longer said to be an atom, it's not therefore said to be what an ion. And we have two types of ion. We have what our cation, which signifies that that particular ion was positively charged. It carries what positive electrical charge. Then we have the what anion, which signifies that our ion is negative charge. Alright. There's something else about radicals, right? Radicals. Now, I believe it's not very common, but I've heard of it before. Now, radicals is a bit different from ions. Now, radicals a whole compound, okay? Now, for ions, we are looking at just a single element carrying a charge. But for radicals, we are looking at what the whole compound carrying a charge, right? The compound is carrying charge. That's what we are looking at in okay. Now, for the radical, we have the popular one will S4 2 minus, all right? There's another one NH4 plus, that is ammonium, all right? etc. So that's for that. So now let's see. Now, it says, all right, the question here is that the number of hydrogen ion in 9.8 gram of hydrogen tetraoxide 6 acid solution is, all right? So want to know. Now, there was a guy that talked about, take note. Now we are looking for the number of ions. Now they say number of moles, they need a number of atoms here, right? Or number of particles. They're asking what was the number of ions. Now there was a particular guy that said 1 mole, all right, of any atom, particle, entity, substance, compound, or element contains 6.02, right? 6.02 times 10 to the power 23 atoms, entities, particles, elements, compound, etc. All right. So there was one guy that said it, and we know that the guy is called Amedo Avogadro, which is Alright, Avogadro, and this is this constant. We call it the Avogadro's what constant. Avogadro's constant, right? 6.02 times 10 to the power 23 atoms, entities, or whatever you are using, right? So that's now we already know that, yes. But now the question is, they ask us the number of what hydrogen ions in 9.8 grams of what hydrogen sulfate 6 acid solution. Now, to do that, we have to use this formula, right? Right? We have to use the former formula, our number of moles formula, which says number of moles equals to what? Mass over what? Molar mass. Now, before we proceed, we have to calculate what? The atomic mass of what? Sorry, molar mass of what? Hydrogen sulfate 6 acid. Alright, so to do that, our H2SO4, molar mass of what? H2SO4 becomes what? Hydrogen is what? 1 times 2 plus sulfur, which is what? Sulfur is 32. Alright, sulfur is 32. Then plus oxygen is 16. But how many moles can we see there? 4. 16 times 4. So if we do that, our answer is what? Let's first calculate it because we don't have time. 2 plus 32 plus 64. That's 98. So 98 gram was per mole. 98 gram per mole. Alright, so since you already know that it's 98 gram per mole, then what is our grams? 9.8 grams. So take notes before I proceed. Alright, I know you might ask, why am I finding the number of moles? Because why? According to Avogadro, he said 1 mole of any element, substance, compound, or anything contains 6.022 atoms, entities, particles, whatever you want to use. But now in this question, they are asking us what for the number of hydrogen ion. But what we are seeing is gram, is mass, not mole. So that's why we have to convert first to mole before we can now know that okay, 1 mole of hydrogen ion contains this. So we have to first know, we have to convert to number of mole before we can solve. Because if we use 9.8 grams to just solve, it will be wrong because it's in mass. We have to convert to mole in order to know what are how many, like in order to know that okay, 1 mole of hydrogen ion contains this, right? So since is that you can add the number of moles equals to mass. Mass is what 9.8 gram over what 98. So if you do that, 9.8 divided by 98, that was 0.1, right? That becomes that gives us what 0.1 mole. Alright. So now, before we proceed, alright, we have to first of all look at the dissociation. That is the splitting of this hydrogen sulfide. Hydrogen sulfide, yes, that is hydrogen total sulfate 6. So H2SO4, when splitted, gives us two things, alright. It gives us H2 hydrogen ion, alright, plus one sulfate, one of these tetrahydrogen sulfate 6. One of these tetrahydrogen sulfate 6, yes. So it gives us what? S1 SO2 minus, right? So that's to tell you that 1 mole, therefore, I can now say that 1 mole of this H2SO4 will give us what? How many ions? How many hydrogen ions? How many hydrogen ions can it give us? 1 mole. It's going to, when you dissociate it, 1 mole will give us what? 2 hydrogen ion. Alright, give us what? 2 hydrogen ion. Then what will 0.1 mole now give us? 0.1 mole of the same H2SO4 will now give us what? We don't know yet, X. So when we cross multiply this thing, alright, this now gives us our X now becomes what? Alright, 2 times 0.1, which is now equals to what? 0. Okay, okay, it's giving us what 0.2. So it's going to give us what 0.2 mole. Right? So 0.2 mole. So that tells us that 0.1 mole of H2SO4 will give us what? Right? Okay, will give us, sorry about this guys. Right? So 0. Yes, will give us what? 0.2 hydrogen what? Ions. Right? So Okay, sorry about this, guys. I think it's a slight mistake. Alright, so basically when we dissociate this, one mole of this H2SO4, alright, will give us what? Of course, will give us two hydrogen what ions. Two moles. Two moles, yes. That's what supposed to write. Two moles of what? Hydrogen what ions. Right? Two hydrogen ions. So 0.1 mole of the same hydrogen tetrahydride is 6. Now give us what? 0. Okay, now give us what? X. So when you do that, X is now equals to what? 0.1 times 2, which is now equals to what? 0.2 moles, 2 mole of hydrogen was ion. So since you already know that it was 0.2 moles of hydrogen ion. So now, and then let's recall. Remember Avogadro's constant. He said that any substance, right, particle, compound, ion, or molecule contains 6.022 times 10 to the power 23. That is its constant. So that is to tell you that 1 mole of a hydrogen ion can give us what? 1 mole of what? Of a hydrogen ion. 1 mole of, okay, I think I'll write this part so that we don't bend too much. Okay. So 1 mole of hydrogen ion, 1 mole of hydrogen ion will give us what? 6.02 times 10 to the power 23 ions. So since 1 mole will give us what? 1 mole of hydrogen ion will give us 6.02 times 10 to the power 23 ions, according to Avogadro, that's what he said. Then how many ions will 0.2 mole of hydrogen ion give us? Alright. So when we cross multiply, this now becomes what? 0.2 times 6.02 times 10 to the power times 10 to the power 23. Right? So when you do that, our x now becomes what? 0.2 times 6.02. Alright. So that will give us what? 1.20 times 10 to the power 23. So 1.20 times 10 to the power 23 ions. Alright, so the correct answer is what? Option D. Right, now let me go over it again. So they were asking us for what? The number of what hydrogen ions in 9.8 gram of hydrogen tetrahydrosulfate 6 acid solution. Right? Now, but we cannot solve. Why? Because according to our they said 1 mole of hydrogen ion atom should contain 6.022 times 10 to the power 23 ions, right? But they're asking us in grams. So we have to convert this gram to number of moles so we can solve. So when doing that, we furtherly did that. Then after solving, we now did 9.8 gram divided by the atomic mass, the molar mass, sorry, of the whole compound, which is hydrogen tetrahydrosulfate 6. So we got our answer. Then we now proceed to dissociate this hydrogen tetrahydrosulfate 6 here. Why? Because we needed to know that if 1 mole of hydrogen tetrahydrosulfate 6, right, can give us 2 moles of hydrogen ion, then 0.1 mole will now give us what? X. So when we do that, we get, that means if one of these can give us 2 moles of hydrogen ion, then 0.1 will now give us what? 0.2 moles of hydrogen ion. Alright, so when we do that, after solving, we got an answer to be 1.20 times 10 to the power 28 ions. Alright, so now let's move, guys. Alright, let's move. So, all right. So now let's move. Let's move, guys. All right. Let's move. So, next question says 1 mole of a compound NHCO3 has a mass of 84 gram. Calculate the relative atomic mass of N. Now, this is it. This question is very easy. Right? It is not even difficult at all. Right? It's not difficult at all. Why do I say so? Now, this is the compound I was given. Now, they actually was convict, like hide the first element. Right? So this is the compound I was given. NCHO3. Okay, NHCO3. Sorry, NHCO3. Alright, and you remember you agree with me that usually if we should calculate the individual masses of this element and add everything together, it will give us our molar mass, our relative molar mass of the compound, the whole relative molar mass of the compound. So that's the thing that right NHCO3 now equals what molar mass of okay, let me just say relative molar yeah okay. So let's say it is the relative atomic mass, relative molar mass, yes, RMM. That's what I should say. So this now was the relative molar mass of the whole compound. Alright. So since and now remember they stated the relative molecular mass, right, of the compound to be was 84. They said 1 mole of a compound MaCO3 has a mass of 84 gram. Calculate the relative atomic mass of N. Now if you're only looking for N, we don't know, right? So how do we look for N when we don't know all this? Of course, we know it because why? It was stated in the question. So NH, while when they added everything, when they added the individual elements, it gave them 84 gram. So the question is, how do we now find N? All right, it's very simple. It's not difficult at all. So what we do here is simple math, arithmetic. We collect items here. All right, so we don't know N, so we put N like that. Plus hydrogen is what 1, plus carbon is 12, plus oxygen is 16. Atomic mass of oxygen, or we can say the molar mass of oxygen is what? 16. 16 times how many moles can we see there? 3. Alright, equals to what? 84. By the time we do this, this is what? N plus this is 13. 13 plus 48, that should give us what? 61. So equals to what? 84. So we can now collect items from this place. When we collect items, our M now equals to plus 61 moves to the other side, becomes minus 84 minus what? 61. So the relative atomic mass of M is now what? 23. Alright. And from what we know, there's a particular element that has a molar mass of what? 23. Alright. So since it's 23 gram, then we know that it is actually what sodium. Sodium has 23 as its what atomic mass. So the correct option is what option D. Right? Although they didn't state it, but we just know that it's sodium. That is the element that they are talking about. That is the element N. Is sodium. Alright, take notes. Now let's dish out other questions. Okay. So before we proceed, I want to know if you guys are with me. Okay, if you guys are with me. So I'm trying to see how. If you are with me, I wanted to see the live chat to know. Okay, just give me few minutes, guys. I believe you can see. I believe you can see it. Okay. All right. So let's proceed. So the next question we have is next question we have here. Now next question we have here is I see you guys now. Oh, all right. Okay, I see you guys. Finally. Okay. So if you can see me, just drop a live chat, please. You can see me. Okay, very nice, very nice. All right. Okay. So let's proceed. So now I can now move. Okay, sorry this awkward. Right, it's just that this is like my first live, so I'm just trying to see how you guys are following because I'm used to feedback, live feedback. I want to know if you are following. That's why I say I'm pausing to see, to check. I'm just trying to check with my phone and see whether you guys are there. So and somehow I was having issues with putting out the live chat, so that's why we are on pause. But now that I can see you guys are joining the class, there's no problem. We are going to fire down immediately. All right, so now let's continue. So we are here, we are here. Now let's proceed. So the next question, question 4. So let's see how we can quickly rush. So just be with me, be with me, be with me, be with me. Okay, so we are going to be solving the next 3. We are taking 3 because of our limited size, limited board size. So all right, so to just make it fast, let me quickly dictate let me quickly write these questions. And the next question we have here, which is question 4. All right. It says upon heating. Now this is technical. We think we are going to use our head for this question. All right, we are going to use our head. I believe you guys can follow. Upon heating 1.25 gram of a solid. All right, of a solid, comma, upon heating 1.25 gram of a solid, 280 cm cube, all right, of a gas, all right, measure that STP, STP were involved, all right, were involved, all right, and a residue and a residue of 0.7 gram was left, right? And a residue of what 0.7 gram was left. Calculate, since you calculate what the molar mass of the gas. Calculate the molar mass of the gas. Calculate the molar mass of the gas. The options given here are, option A, 64 grams, option B, 44 grams, option C, we have 32 grams, and option D, we have 16 grams. Right, now question 5, our next question, these are 5 questions for tonight. How many moles of how many moles how many moles of how many moles of iron 203, right? How many moles of iron 203 are contained in 1 kilogram of the compound? All right, so it's not also very difficult at all. 1 kilogram of the compound. Option A, 3.125 mole. Option B, 0.312 mole. Okay, 3.125 mole. Option C says 0.625 mole, and option D 6.25 mole. All right. So this is question. Then the last one says how many. Right. Option 6. How many atoms of oxygen? How many atoms of oxygen? How many atoms of oxygen are present in 8.8 gram of carbon dioxide? Right. First option says 6.02 times 10 to the power 22. Option B says 2.41 times 10 to the power 22. Option C says 2.41 times 10 to the power 23. And option D says 2.41 times 10 to the power 24. Right? Okay. All right. Let me jump the book so that I can solve quickly. All right. So now let's proceed quickly. Let's do quickly. Now, how do we tackle the fourth question? All right, very easy. Now, take notes, guys. They said upon heating 1.25. Okay, upon heating 1.25 gram of a solid. Now, that is to say that heat was added to the solid. All right. Now, then I said of a solid 280 centimeter cube. Now, when 280 centimeter cube, that what comes to your mind immediately is that it is what gaseous, because gas occupies volume. Yes, volume is used for gas, all right? And since volume is used for gases, now gases is measured in what centimeter cube or decimeter cube or ATM, depending on that, all right? Gas volume is usually what centimeter cube and what decimeter cube, all right? That's dm cube and what cm cube. Now, you now look at the question and you are like, okay, upon heating 1.25 gram of a solid, 280 centimeter cube of a gas, measure that STP. Now, guys, what's STP? It's very simple. Standard temperature and pressure, right? It is used most times when you are calculating for quantitative analysis and of gas stoichiometry, mole concept, electrolysis, and gas laws, right? We use standard temperature and pressure. Now, the standard temperature is what? The standard temperature is 273 Kelvin, while the standard pressure is one. Okay, okay, it varies. Okay, 70, that's 160 millimeter mercury. All right. Okay, that's for that. Or you can use 1.02. Okay, you can use 1 ATM. Okay, but the one I mostly use is just 70 millimeter mercury. You can also check for the other constants. All right, there's store. You can use store to measure pressure. You can use ATM to measure pressure. You can use millimeter mercury to measure pressure. That you can use atmospheric pressure to measure pressure in chemistry. Right, that's what that. But we're not looking at pressure today. So 20 centimeter cube of a gas measured at STP were evolved and a residue of 0.7 gram was left. Now this question is not hard. That is to tell you that the solid is actually a sublimable solid. That is a solid that can change its state from solid to gas directly. It's not turned into a liquid. That means it was heated and the solid changed to gas directly. Alright, so to solve this question, first of all, you have to know that you want to calculate the molar mass of the gas. First of all, you have to know the mass of the gas that occupied this 280 centimeter cube. Now, let's come back. You know that the mass of the gas is not 1.25 gram. It is the mass of the solid that is 1.25 grams. All right. And they said it left a residue. The residue, that means the leftover after the solid sublime. That means the solid sublime to an extent that it now paused. It didn't sublime anymore. It now remains just 0.7 gram of that solid. So that is not the mass. The 0.7 grams is not the mass of the gas, and 1.25 is not also the mass of the gas. So how do we now find the mass of the gas? Very easy. All right. So to find the mass of our gas, mass of gas now be equals to what? You subtract what? 1.25. You subtract 0.7 gram away from 1.25 grams. So mass of the gas now be 1.25 minus 0.7. Right? Which will give us what? All right, which will give us 1.25 minus 0.7. Oh, sorry guys, 1.25 minus 0.7. Oh, my calculator just stopped working all of a sudden. 1.25 minus 0.7. What is happening? What is happening? Wow, this is very okay. Just give me a minute, guys. All right, sorry about that, guys. There was a big break in transmission. Okay. All right, so where did we stop? So I said since the solid is 1.5 gram and that was the initial gram was 1.25, then after it sublimed, all right, it had a residue. The remaining mass was 0.7 gram. So, but that is not the mass of our gas. To get the mass of our gas, we have to subtract 1.25 grams away from us. We have to subtract 0.7 gram away from 1.25 gram. So to do that, this now was 1.25 minus 0.7. Wow. Again. It was 0.7. Okay, okay, that will just give us just just that should give us 0.55 gram of what of the gas. Okay, so 0.55 gram of the gas. That's what to give us as our answer. So then we now proceed. So now find, take notes. We have already found out gram to be what the mass of the gas to what 0.55 gram. So take notes. Remember, we are still talking about STP. So since we are talking about STP, that is to say that 0.55 gram. Okay, now 0.55 gram of that mass, okay, of the gas, 0.55 gram of the gas occupied 280 centimeter cube. All right, so that is for that. So how many grams in mass will now occupy? All right, we now occupy what? Let's make a split so. I don't know. This has been very stressful.
0.25.
Okay. All right. So actually, this one is actually correct. All right. So now let's proceed. So you already know that the volume at STP is what 280 what cm cube. All right. For now, there's a formula that connects volume and mass together in mole concept, and that formula is this. Okay. So we now to find our number of moles. All right. So or our mass, right? Okay, to find the number of moles, we now use this is 280 cm cube, and as STP, all right? Remember it's STP. We are supposed to use what 24 dm cube, all right? We are supposed to use what 24 dm cube. So we are going to convert this to 80 centimeter cube to dm cube. So by doing that, we convert volume at STP, the gas occupied. Okay, as STP, let me write that this as STP, the gas occupied at STP 0.55 gram of the gas occupied 280 cm. So we have to convert 280 cm towards dm cube so that we can solve. Alright, so to do that, 280 centimeter cube over 1000 dm cube makes a dm cube. So this can become what 0.28 dm cube. Alright, so this is 0.28 dm cube. Alright, then we can proceed. So if 0.55 grams occupied 0.28 dm cube, alright, how many grams in X will occupy 22.4 dm cube? So by doing that, if we should multiply,
Calculator is going to finish me today. Right? Right? If you should multiply,
cross multiply, this now becomes what? 0.55 times 22.4 divided by what? 0.28. So
the calculator is really failing me. So, alright.
so if you are
So we just react on the live chat so that I know you guys are with me. 0.55 times 2.4, alright, divided by 0.28.
okay, so that's 4 grams. Alright, so I'll go by it again shortly. So I'll answer it what option B. Now they said that we should what upon heating 1.25 gram of a solid. Upon heating 1.25 gram of a solid, that means 1.25 gram in mass of a solid was heated. Then the solid after heating sublimed to produce 280 centimeter cube of a gas. That's the volume of the gas as STP. Alright, so after everything, after it sublimed, there was a residue mass, which there is residue of the solid. The remaining mass of the solid was 0.7 gram. So to first of all, So solve, you have to first know, okay, what particular mass of the gas release this 280 centimeter cube that will follow. That's what we did here. So after minus 1.25 minus 0.7, which now give us 0.55 gram. So at STP, we can now say therefore that STP, the okay, at STP 0.55 gram of the gas occupied 280 centimeter cube. So okay, in case you don't want to solve it like this, you can also use the other method, because at STP, 1 mole of a gas should contain 22.4 dm cube, or all right, sorry about this, guys. Are you guys still with me? Okay, all right, I see. All right, at STP, all right, okay, sorry about that, guys. So at STP, we know that a particular gas should contain 20.4 dm cube or 22,400 or cm cube. So in case you don't want to convert, you can just solve normally and then do that. But when solving, then when you are, that means you are solving, you now use 280 cm cube over what 22. You just use cm cube for everything. Alright, but I wanted to convert, so I prefer it like that. Right. So 20 cm cube over what, over 1000 will give us 0.28, because we converted, give us 0.28 dm cube. So by doing that, after we cross multiply and we calculated, we now discover that the gas mass was actually what, um, 44 gram. That's the molar mass of the gas. Take note of that. That's the molar mass of the gas. It was 44 gram. So we now move to the next one. They said how many atoms, how many was moles of iron 2 oxide are contained in 1 kilogram of the compound. How many moles? So this is number of moles. We are looking for what? The number of moles of this iron 2 oxide that is contained in 1 kilogram of the compound. Now take note, before you even continue, firstly, there's something that is very attribute there, which is our mass. All right, 1 kilogram. Why are we supposed to use 1 kilogram? Like, this question is fast. It's a trap, right? It's a trap set for us. Now take note, there's something in science, in physics, you use kilogram, all right, for your masses to what, measure. Kilogram is used for measurement of masses in what physics. Why? Because we are talking about animate objects, like larger masses. Yes, the body in movement, something in motion, friction. Yes, do you understand? That's why we use gram. But in chemistry, we use gram because we are talking about all way more smaller matters, molecules, atoms. So we can, in fact, atom is not even gram. Atom is atomic mass unit. So we use way smaller units, SI is for mass chemistry. Right? So firstly, before you start anything, before you solve this question, the number two, how you find the power of moles of iron 2 oxide, you have to convert this kilogram to mass, right? So that means you already know that this was 1000 gram makes what 1 kilogram. So using our formula, using number of moles is equals to what, mass over molar mass. This formula, using number of moles is equals to mass over molar mass. We already know that the number of moles is, that's what we are looking for. Then the mass that was given is what, 1 kilogram, all right? 1 kilogram, which was 1000 over the molar mass. Molar mass we don't know yet, but we are going to know because we are definitely going to solve it now. So now we want to solve the molar mass of iron 2 oxide. So iron 2 oxide becomes what? Okay. So what is iron? The atomic mass of iron is what? 56, right? So 56, but how many moles can we see there? 2. So 56 times 2, because it's iron 2. Two atoms of iron coming together to what? Combine with what? 3 atoms of what? Oxygen. So this 56 times 2 plus 16 times 3. Oxygen is 16, but we can see 3 atoms. So by doing that, it's 6 times 2. 6 times 2 gives us 112 plus 48. That's 160. So 160 was gram per mole. Alright, that is our atomic mass. That's our molar mass of this compound. So since we already know our molar mass, substitute number of moles becomes what? 1000 divided by what? 160. So number of moles is 6.25 mole. Let's calculate for you. 1000 divided by what? 160. So that will give us what? 6.25 moles. So our answer was 6.25 mole. Alright, so that means we have 6.25 mole of iron 2 oxide in 1000 gram of that substance. All right, so that's for that. So now let's proceed to the last question. Right, it said how many atoms of oxygen are present? To the last question. Right, it said how many atoms of oxygen are present in 8.8 gram of carbon dioxide? How many atoms of oxygen are present in what? 8.8 grams of carbon dioxide. Okay, so first of all, they asked us for, all right, now they asked us for how many atoms of oxygen are present in 8.8 grams of what? Carbon dioxide. Firstly, we have to convert from what? From this gram to number of moles. Do you know why? Yes, we just have to convert, right? So that we can know. Because from the moles we cannot tell the atom. Right? So to do that, first let me clean this other part. How many atoms of oxygen are present in what? 8.8 grams of what? Carbon dioxide. Firstly, we need to determine what our molar mass of carbon dioxide. So the molar mass of carbon dioxide of CO2 is carbon is 12, right? 12 plus oxygen was 16 times 2, which is 32. So this should give us what? 44 gram per mole, right? 44 gram per mole is the answer. So since we now have this, we can now use our formula using number of moles equals what? Mass over what? Molar mass. Right? So by doing this, this now becomes what? What is the mass? 8.8 gram. 8.8 gram over molar mass 44. So when we do this, let's see what we have here. The number of moles of carbon dioxide is now what? 8.8 divided by 44. That should give us 0.2 moles. So that's now what 0.2 moles. Right? So now take note, guys. So that is to say that if 0. If okay, now this is very simple, right? If 1 mole, all right, of carbon dioxide actually give us now look at something in carbon dioxide. This is CO2. In carbon dioxide, how many moles of oxygen can you see there? You can actually see 2 moles of oxygen in carbon dioxide. So that's to say that in 1 mole of carbon dioxide, we can produce 2 moles of oxygen. So in 1 mole of carbon dioxide, if 1 mole of carbon dioxide can give us 2 moles of oxygen, all right, of oxygen, then how many with 0. How many moles of oxygen with 0.2 moles of carbon dioxide give us, all right? So by doing that, we now want to cross multiply. So that's to say x. So our x now was 0.2 times 2, which is now what? 0.4. 0.2 times 2, which is 0.4. So that's to say that in 0.2 moles of carbon dioxide, we can get 0.4 moles of oxygen. It's 1 mole of oxygen, all right? Now take note. So since we now know that, okay, 0.4 mole of oxygen can be produced from 0.2 moles of carbon dioxide. Now remember, why am I doing all this? Because the goal was to get the most of your oxygen, because they said how many atoms of oxygen are present. And according to Avogadro's constant, they said 1 mole of oxygen can what produce 6.02 times 10 to the power 23 what atoms, right? 1 mole of oxygen atom can give us what 6.02 times 10 to the power 23 atoms of oxygen. So because that constant exists, since we already know that 1 mole of oxygen atom can give us what 6.02 times 10 to the power 23 atoms. You know why I'm using this? Because the relationship that asks for atoms, all right, is that you can use to calculate for the number of atoms is Avogadro's number. Yes, because Avogadro completely stated that every mole of a substance has 6.022, 6.022, yes, 22 can be used, or 6.022 times 10 to the power 23 was atoms. So that's what that. One mole of oxygen atom can give us what? 6.02 times 10 to the power 23 atoms. So what will 0.2 moles of that same oxygen now give us? If one mole, right? If zero, so what will 0.2 mole of oxygen atom now give us? Since one mole of oxygen atom can give us 6.02 times 10 to the power 23 atoms, so what will 0.2 mole give us? Right? X. We cross multiply. So by doing that, we now have 0.2, x equals to what? 0.2 times 6.02 times what? 10 to the power 23. So x, that's atoms, remember it's atoms. So multiply 0.2 times 6.02 times 10 to the power 23. Alright, 0.2 times 6.02 times 10 to the power 23. Alright, so that gives us 1.204 atoms. So that's to say that you can get 1.204 atoms of oxygen in 8.8 gram of what carbon dioxide. Option. Okay, is it one? No, this is supposed to give us 2 points. Okay. Oh, sorry, guys. There was a mistake. Yeah, 0.4. I was saying that there's a mistake here. It's 0.4 moles, not 0.2. Why? Because we already calculated earlier and we saw that from 0.2 mole of carbon dioxide can give us 0.4, not 0.2, sorry. So when you multiply that, it's 0.4 instead. So when you multiply that, 0.4 times what? 6.02 times 10. Okay, that should give us 2.2, 2.4. Yes, okay. Let me show. Because, wow. Okay, so 0.4 times 6.02 times 10 raised to power 23. All right, 2.408. That's approximately 2.41 times 10 raised to power 23. Option C. All right, 2.80408. That was the answer. So we have approximately 2.41. So therefore we can say that we have 2.41 times 10 raised to power 23 atoms that is atoms of oxygen present in 8.8 gram of what carbon dioxide. We therefore have 2.41 times 10 to the power 23 atoms of oxygen present in 8.8 gram of what carbon dioxide. So that is for that. That is for that. So let me bring out the remaining questions. Many questions we have under this part. Okay. If you are still you can drop a chat on the live chat. All right. And I believe we can see the board very well. I believe we can see the board very well. Okay. Can see the board. Let me see. Let me see. I'm coming, guys. I just want to check for feedback from you guys. Okay. Thanks so much. All right. Hi, guys. Sorry about that. The next thing now, I'm waiting for a new SIM to come out because I don't know. I'm tired of MTN, I'm tired of Airtel. I just had to switch to my Airtel now right away. I had to switch to my Airtel. So, hello, guys. Sorry about the transmission. So, but I presently have MiFi. The MiFi, the network is bad, so I had to move to my MTN. All right, so I'm trying to see how this MTN is going to go. Sorry, so sorry for the break in transmission, guys. I'm really, really sorry about that. So please accept my apologies. Why? Because I had technical issues. When I get technical issues, of course, is network. My network was entered H plus. I don't know why my network was showing H plus. So I tried to move to my Airtel, but my Airtel was giving me issues. So I, after so much experience, it's back. All right. So we have wasted enough time. So let's quickly proceed to the last two questions on manual concept. Then from whole concept, we enter relative how to calculate for your um, percentage composition by mass, then maybe a bit of empirical formula, and that's there we go. So let me read that live chat. Let me check. Okay, for those of us asking, subtracting. Okay, I see you. I see you guys. I see you guys. Okay, I see you guys. Oh, the board is clear. Okay, so all right. Okay, so yeah, somebody texted me and said I should just read the chat. So I'm reading the chat. So you can drop chats, all right? You can drop chats for me so that I can go through it and look at it so that we can proceed. All right. But for now, let's continue. So let's quickly. All right. Yeah. Okay. So we can proceed. All right. So the next question we have is, all right. So I'm going to write the last two questions for no concept. Then we can proceed. The question here says, what is the mass? Question 7. What is the mass? What is the mass of potassium hydroxide present in 500 cm cube of 2 mole per dm cube solution? Right? Okay, solution of the compound. Option A says 40 grams. Option B says 56 gram. Option C says 112 gram. And option D says 28. All right. Number 8. Number 8. That's the last question under this part. Okay. That, I think that's for this one. So now let's solve this. Let's solve this. Right. So now take note. Before I post, okay, let me solve this before I take this. Okay. So for the solution of this question, right? As I said, what is the mass of potassium hydroxide? Are you guys following? Okay. Tough. Somebody said tough. All right. It's all good. It's all good. All right. So all right. So now to solve for this question, normally I would have said number of moles is equals to blah 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 blah. No, but in this place, we are not going to use that because if you do that, we'll be wrong. Now, there's something that was stated in this place. It's not like the regular questions we were solving. They said, what is the mass of potassium hydroxide present in 500 cm cube? Now, that should tell you that 500 cm cube is the volume, right? Yes. Then 2 mole per dm cube. Now, whenever I see mole per dm cube, they are trying to tell you the concentration of the solution, right, of the compound. So, in this case, we are not using mass over molar mass. We are using this formula Cv, which is concentration times volume over 1,000. Right. So times, yes, concentration times volume. over 1,000. So if you do that, we have this as a formula. What constitution is 500, right, CMQ over 1,000, right, times the concentration is 2 mole per DMQ, 2 mole per DMQ. But now the question is, take notes. Yeah, which is the volume. The volume was 500 CMQ this question, and our concentration was in mole per DMQ. So we have to convert, all right? We have to convert these 2 mole per DMQ to CMQ. So I think that we now have 2,000 CMQ. Okay, 2,000 mole per CMQ, right? That's what we have there. Why did we do that? Because 1,000 centimeter cube makes up 1 DMQ. So we have to convert. So by doing that, this is very easy. So of course, so when we cross multiply, I will do that. We have n is equals to what? 0.1 mole. Yes, this should be not 0.1. Let's be sure. All right. So that's now 500 CMQ divided by 1,000, okay, times, okay, let's just say this cancel this 0 cancel this 0. This is now what? 500 CM, okay, yes. Oh, oh. All right, so let's, okay, my network is back. My network just became unstable just now again. How is cheat? Anything, don't take me. You guys don't take me. I will survive the siege. I will survive. We are going to survive, and nothing is stopping us. Right? Maybe at the end of the day, is to just get a Starlink network, and we are heading there. So now to solve this, and they said the chloride of a metal consists of 79.78 percentage of chlorine by mass. What is the empirical formula of the chloride? Now remember, now recall for empirical molecular formula. Empirical formula just tells us the types of elements or the elements that are present in simplest whole number ratio. But the empirical formula does not tell us the exact mass, all right? The exact mass or the exact, okay, let me not say mass, right? The exact number of moles of each individual element in a compound. Let me explain what I mean by that. Empirical formula will just tell you, okay, this is the ratio of a particular element to another element in a particular compound. But the molecular formula will tell us that, okay, this is the exact number of moles of each of these elements in the compound. So that's the difference. So all those grammar you read from your textbook, no too much talk, right? That's just what they are trying to say, right? Now, to solve for the empirical formula, usually we already know that they said the chloride of a metal, that means, and the metal they said is M. They denoted it, it was hidden, it was M, all right? So let's say this is M, and this is the chloride. Now, when I said percentage by mass of what? 79.8, 79.78 of chlorine. So that is to say that chlorine has, by mass, all right, it has 79.78%. But now they didn't state the percentage by mass of that N, of that metal, all right, of that metal. So how do we get it? It's not even difficult at all. It is very easy. So now let's use our issue, our common sense. Now they told us that there is two constituents of something. One is 79.78%, but they didn't give us the other one. What do we do? It's very simple. Since we know that if we add the percentage, and remember, percentage by mass, percentage over 100, that means if you add the two, it's supposed to give you 100. So, but since they gave us only one and then they give us the other one, it's very easy. What do? We minus 79.78 from 100 to get the percentage by mass of the metal N. All right. So by doing that, this now becomes 100 minus 79.78. All right. And hope my calculator comes up. 100 minus 79.78. Oh, Jesus. All right. 100 minus 79.78 will give us calculator is just fucking up. Okay. All right. All right. So 100 minus 79.7, that should give us the metal is equals to what? Yes, our metal is actually, sorry about that. My calculator was completely dormant. I don't know why. So 100 minus 79.78 should give us 21 points. Okay, or 20, yes, that's 20 points. 20 points. Okay, 20 points. 31. Yes, actually, it was 20.32. Sorry. Yes, 20.32. Yes, 20.32. So since we already have the percentage and mass of of our M, the metal, so this is now what 20.32. Then chlorine is now what 79.78. Okay. So this after this part is going to really give us a lot of stress. A lot of stress. Okay, so I think this is what I'll do. I'll pause this formula for now first, then we move to the next part. We have another part. So I'm sorry guys, but tomorrow we are going to continue this because I'll be sorting out the calculator. My calculator is just too bad. And for speed, we need a calculator to do this. I'm very sorry about this. This is incompetence from my end, but I didn't know that it's going to turn out to be like this. So but let's pause this, all right? I remember where this question stopped. So we'll do it tomorrow, but we'll continue from radius reaction. So let's skip one to the next one. All right. So because of time, let's quickly move to radius reaction instead. All right. So because of time and because of our calculator, let's quickly move to radius reaction. So we are moving to radius reaction. All right. So the first question here we have is, all right. Now they say the first question is oxidation number of oxygen is different from its value in water in the oxidation number of oxygen is different from its value in water in option A. They said the first one in option A, the option was SO2. Okay, SO2. Option B, H2O2. Option C is H3O plus. Then option D is what OH minus. Now, this was oxidation number calculation. All right. Now, firstly, this is very simple question because you don't even need to solve. Now, if you check, yeah, let's analyze each of this question. For the first option, option A, this is the oxidation number of oxygen here. Sulfur in this place is giving like a metal, right? It's actually giving four of its giving like a metal, right? It's actually giving four of its what atom, its atom towards oxygen. So that is to tell you that because it is given, oxygen is said to be electronegative here, is a receiver, all right, it's an acceptor. So oxygen here is actually being what? Um, okay, oxygen is actually being oxidized because it is gaining electron, all right. It's actually being what? Okay, so the oxygen is actually what being reduced. Okay, the reducing agents is oxidized and oxidizing agent is reduced. Yes, oxygen is the oxidizing agent and it's actually what being reduced. Okay, so that's for that. So this one is already out. Sulfur is giving, oxygen is collecting. So Yeah, oxygen is what? -2. Right? How do I know? -2 because I don't want to calculate. Okay, let's see. Let's just calculate it. No problem. But let's calculate it. Sulfur here is 4. Right? 4 plus oxygen is actually, we don't know. 4 plus x times 2. Normally, when you are calculating for your station number, you equate to 0. I don't know if you guys can see this. You can see board anymore. Let me make it bigger. Right? So, solution for this question. Okay, let's just calculate each of them. Right? So, for 4 oxide, right, we want to know the oxidation number of sulfur of oxygen here. Because of 4 oxide, yeah, sulfur is 4. Now, you might want to tell me, sulfur is -2. Yes, but in this place, sulfur has an oxidation number of 4 plus we don't know oxygen, we want to find oxygen, x times how many oxygen can we see? Times 2. In bracket, we equate it to 0. So this now becomes 4 plus 2x equals to what? 0. So when we do this, this now becomes 4 equals to what? 4 equals to, okay, 4 equals to what? This one will go this way, that become -2x. So x is now equals to what? -2. So oxygen here is -2. Do you understand? And in water, H2O. Remember, they said, the oxidation number of oxygen is different from its value in water. That means they are looking for the oxidation number of oxygen in water is -2. So which of these compounds has the oxidation number of oxygen different from the value of the oxidation number in water, the oxidation number of oxygen in water? So they are looking for a different value from that of oxygen in water in these options here. Do you understand? So that's what we are doing. So SO2, then we look for the next one, the same thing. For you to even see, oh yeah, that means definitely oxygen is -2 because 3 atoms of hydrogen. Okay, let's calculate it. No problem. I feel just calculate it so that we're not going too much talk. So this is hydrogen. Of course, hydrogen is 1 times 3, right? Plus x equals to 0. So this now becomes 3 plus x, alright? So, alright, okay, yes, 3 plus x. So when doing this now becomes what? -3. Yes, x equals to what? -3. Although, yes, you might say -3, but it's not actually -3, sha, it's -2. Why am I saying -2? Because this plus here, H3 is 3 hydrogen. Normally, the valency of oxygen is -2, but 3 hydrogen atoms came to combine with it. So because it's just like I needed two items to complete my structure. Then somebody now brought 3, I had excess, and it's 2 that I need. That's the maximum I need. So that means I'm willing to give that one extra to somebody else that needs. Yes, that's what's happening here. So this H3 plus, all right, means that this compound will still give one more electron, so it's actually -2. Now, if we still do the same thing here, of course, the same thing, oxygen is what? -2. So the only one that is different is what? Option B. It has even further thoughts. Why? Because let's calculate H2O2. Okay, let's calculate H2O2. The oxidation number of hydrogen is what? Of course, we know it's 1. All right, but how many moles can we see? 2. All right, 1 times 2 plus oxygen, we don't know, which is what? X. Once we find oxygen, X, but times how many moles can we see? Times 2. We equate it to 0. Why we equate it to 0? Because whenever you are just going like that, this time you don't need too much explanation. Whenever you are solving for your what? Oxidation number, you equate it to 0. So this now becomes 2 plus 2x equals to 0. So by doing this now becomes what? 2 minus what? 2x. So 2 is x is now equals to what? -1. Do you understand? So in this place, so this is called hydrogen what? Peroxide. Now there's a secret. Now in peroxides, oxygen is -1. The oxidation number of halogens, right? Not halogens, oxygen mostly, right? Oxidation number of oxygen is -2, except in peroxides, where you have things like this, where it is -1. Another example of peroxide is Na2O2. Oxygen there too is -1. Then hydrogen, on the other hand, has the oxidation number of +1, except in hydrides, metallic hydrides. What do I mean by metallic hydrides? When you see things like this, right? where you see things like this. You now see calcium hydride, all right, sodium hydride, potassium hydride, all right. So hydrogen is not plus there, it's minus, it's a receiver, all right. Take note of that. So now the next question, the next question, the next question says, in which of the following is gallium showing an oxidation number of 37? In which of the following is gallium showing an oxidation number of 37? So to make it fast, we have to be very fast. There's no time. There's not much time on that. So let's just be fast. Let's see what we can do. Alright, in which of the following is gallium? Gallium is a metal. I know it's not very common to you guys. It's actually, I don't know, okay, rhodium, okay. It's actually the zinc, copper, nickel, gallium, copper, nickel, zinc, gallium, germanium. It's actually 31 element in the periodic table. Alright, so that's that. Then now they said in which of the following is gallium showing an oxidation number of +3. Alright, showing oxidation number of what? Oxidation number of what? +3. Alright, option. The first one, oxidation number of +3, we have NaGaO. Option B, we have NaGaOH. Option C, we have NaGa bracket OH, NaG bracket OH 3, and option D, NaGaO3. So we are going to solve for each of the oxidation number. So how do we solve for this? Very easy. All right. Let me see the live chat. All right, so now let's proceed. So to solve for this, now we start from the first one. To solve for option A, all right? So A, which is sodium gallium oxide. To solve for this, we know that sodium has. Now take it when solving for the oxidation number, what you are interested in is you are actually what adding the valency of these elements together, all right? Just like when you solve for your molar mass of the compound. That's how you're solving for your what? For your oxidation number. So by adding in molar mass, we want to calculate the molar mass of the whole compound. We add the masses, atomic masses or molar mass of the individual elements. But in oxidation number, we are adding not the atomic masses or molar mass. We are adding the what? Valency or otherwise the oxidation number of these elements. So in this case, sodium has a valency of +1 here, right? So +1 plus, all right. Okay, let's just write 1, not +1. +1 plus gallium, we don't know gallium, so it's X, all right. Then plus oxygen is what? -2 equals to 0. So this now becomes 1 plus X minus 2 equals to what? 0. So this becomes X is now equals to what? 2 minus 1. X is equals to 1. So in this place, in the first option, gallium is +1, not +3. So move to the next one, option B, let's solve. All right. NaGa, all right, bracket OH4. Now let's solve. Sodium is also +1 here, all right. So plus gallium, we don't know X. Now plus oxygen here is actually what? -2. But how many oxygen can we see here? minus 2 times. You know, this 4, take note, guys. This 4 that you can see here is affecting everything inside this OH, inside the bracket. All right. So this is affecting everything inside the bracket. This now becomes oxygen. This now becomes 1 plus X, which is gallium. We don't know gallium. 1 plus X plus oxygen is what? 16. No, sorry, not 16. Minus 2 times 4 in a smaller bracket. All right. Then plus hydrogen is 1 times 4 equals to 0. So by doing this, is now what? 1 plus X plus minus 2 times 4 minus 8 plus 4 equals to 0. So this now becomes what? X is equals to what? Okay, let's say 1 plus 4 is 5. Yes, definitely. 8 is now equals to what? Minus 5. So x is equals to plus 3. We have gotten it actually. We have gotten it. Just check it down on the board. We have gotten it. So no need to solve for that. You already know that where gallium is plus 3 is option what? Option B. By solving the oxidation number properly. Alright. I hope you are understanding how I'm getting this oxidation number, if at all. Hope you can understand. Hope you can understand. All right. So now let's continue. Let's continue. So the next question under oxidation number, because of time, let's see. So now they said the possible oxidation number, the possible oxidation number all right. It's not very easy. Okay. So now they stated that the possible oxidation number for an element, the possible oxidation number of an element with atomic number of 17 of 17A, okay, of 17R, right? The possible oxidation number of an element with atomic number of 17R. Now they said option A is what? Minus 1 and plus 6. Option B is what? Minus 7 and plus 1. Option C is what? Minus 3 and plus 5. And then option D is minus 1 and plus 7. So how do we do this? It's not even hard at all. Okay. So they said possible oxidation number. First of all, the important thing here is the element with atomic mass 17. Now, how do I solve this? First of all, very easy. I want to just do it very quickly. Since it has atomic mass of 17, that means that's to tell you that okay, atomic number, not mass, atomic number of 17. Remember, according to our atomic structure, atomic number is the same thing as the proton number, right? And so the proton number is also equivalent to the number of electrons. That is to say, if I have an element that has 5 protons, that means the element will also have 5 electrons. So since the atomic number of this element that we are talking about is 17, that means it has 17 protons, and therefore it's equivalent to what? 17 electrons. So we can draw it, we can draw the structure here. So we have for 17 electrons, we have it like this. This is how we draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay, 10, 11, 12, 13, 14, 15, 16, 17. All right, 17. So since we already know, so without even being told, we already know that this guy is actually non-metal, all right? And since it means -1, it falls under halogens. Halogens usually have an oxidation number of what? -1. So it is between what? -1 and +7. -1 and +7. So the option is what? Option D. -1 and +7. That means you can receive 1 and give this 7. All right, that is outside its what, that is on its atomic shell, which we call the valent shell. All right, so that's for that. So the answer is what? Option D. Why? Because if you check the valent, the atomic shell, all right, the atomic shell, if you check the number of valent electron it has, it's what? It's 7. So since it has 7 valent electron, that means it could possible, it's just a guess, it could possibly give 7 electrons. And since it only needs 1 to complete its octet structure, that means it could what? Receive 1. So it's either it is -1 or it is +7. So take note. So the correct answer is what? Option D. Take note of that. And the next question we have here is, all right. Now, take notes. Take notes. This is another question. All right. Now they said you should consider the following redox reaction. This is redox reaction. All right. Consider the following redox reaction: MnO4 minus. Okay. Let me expand the board. All right. MnO4 MnO4 minus plus 5 ion 2, all right, plus 8 hydrogen ions, right, to now give us this, to give us manganese 2 plus 5 ion 3, all right, plus 4 molecules of water. Now this is a redox reaction. Now the question asks, I don't know if you can see the board. Manganese oxide plus 5 ion 2 plus 8 hydrogen ion. So that gives us manganese 2 plus ion plus 5. Okay, we already know it. We already seen there right now. So then asks, the number of manganese change from. So they're asking us the oxidation number. This is the reactant side. This is the plus side. They're asking us, okay, what is the oxidation number of manganese here, and how was it able to change to the oxidation number in this place? Alright, that's what they are saying. So the first also said, okay, the question is what the oxidation number of manganese changed from. Oxidation number of manganese changed from option A. Oxidation number of what? Manganese changed from. Okay, we have +6 to +2. Option B, we have +5 to. Okay, yes, option B, we have +5 to +2. Option C, we have +7 to +2. And option D, we have +1 to +2. Right? That's very easy. Now take notes. Take notes, guys. Do me. So to explain this part, first I need to read this part, manganese oxide. Right? So for manganese oxide in this place, manganese is actually a transitional metal, right? So it's a transitional metal, and one peculiarity about them is that they have varying oxidation number. The oxidation number is not certain. They have very different types. So they can be +7, they can be +4, they can be +2, they can be +3, they can be 0. You understand? Yes. So those are transitional metals. So it varies. They have varying oxidation number. So in this place, the truth is 4. All right. Manganese give out 4. Okay, not 4. 7. This is 7. Right. Manganese gave out 7 of its electrons to oxygen. This, no, oxygen is what? -2. All right. Oxygen is -2. All right. All right. Okay. All right. I was saying something else. All right. I was saying something else before. That's why. Okay. So it's all good. Okay. Okay. All right. So back to what I was saying. All right. So I believe you guys are seeing. We'll be running this very fast as we can. So MnO4 in this place, manganese combined with oxygen. 4 atoms of oxygen came to collect from manganese. So manganese gave us 7 of its electrons towards oxygen. How did I know it was 7? Now, how you know in this type of question, how you're supposed to know is from the reaction. Now, this minus sign up there shows that this compound is not stable yet. It needs one more electron. Actually, there's an invisible one there, but they don't usually write it. If it was 2, you would have seen -2, right? But if it's just a negative or positive sign, that means either it's +1 or -1. All right. So manganese oxide, it means that it still needs one. Now, if you check this, this is a transitional metal, this is what a non-metal. That means, and oxygen here is -2. Oxygen is -2. -2 times 4 is 8. So oxygen collected about 8 electrons, while manganese was only willing to give 7. So now, if you do 7 plus 8, all right. Now these are all right. Manganese, right? O4. Oxygen, right? Hold on. Manganese O4. Oxygen is -2, and -2 times 4. That's 8. So oxygen collected 8 minus received 8. And the manganese was 7. Donated was 7. Right? So if you do -7 plus 8, what are you going to have? -1. That is the minus you are seeing here. That's the minus you are seeing there. Minus. So that's what it means. So, so when you answer that, you now see -1. So that's the minus sign you have there. So that's to tell you that manganese here is what? +7. So in this case, what I'm saying +2. So the answer is that it changed from what? +7 to what? +2. Option C. Take from that. Take from that. Alright. Now let's move. Let's move. Next question. And next question is all the following are redox reaction except all the following are redox reaction except okay. Question. I'm not in the chat question anymore. Alright. So I think this is will change. So all these are some that question. Just know that all the following are redox reactions. All the following are redox reactions except so A we have zinc plus H2SO4. So that give us what? Zinc SO4, zinc sulfate plus what? H2. Option B, calcium trioxohydrocarbonate 4. So now give us calcium trioxocarbonate 4 plus water plus what? Carbon 4 oxide. Alright, then we have the next one which is what? C, hydrogen plus O2. So now give us what? Of course, 2 moles of water. Then we have the last one which is what? 2 HNO2 plus 2 hydrogen iodide. So now give us 2 moles of water plus 2 nitrogen 2 oxide plus iodine. Now let's look at the following reactions. Alright, they said which of these all of the following are redox reactions except, and let's see. Now, if you observe this zinc here, now redox reaction actually can be defined in about 6 contexts. Alright, so in 6 contexts, we can divide redox reaction in the context of what? Oxygen, right? In the context of hydrogen, and then we can define it in the context of what? Electropositivity. We can also define it in the context of what? Electronegativity. Then we can define it in the concept of what? Oxygen, hydrogen, electropositivity, electronegativity, electron loss, electron transfer, and then the last one, oxidation number. Alright, so I'll just briefly explain it shortly before we can continue. Alright, so in terms of oxygen, redox reaction, we have redox. Remember, redox is a combination of reduction and oxidation. So I can definitely say that redox reaction is a type of reaction whereby reduction and oxidation is occurring simultaneously. As reduction is occurring, oxidation is also what's happening in the reaction. So that's what the redox reaction is. Now, in terms of oxygen, reduction is now what? The removal of oxygen, while oxidation is the addition of what? Oxygen. In terms of hydrogen, reduction is what? The addition of hydrogen, while oxidation is the removal of hydrogen. In terms of electropositivity, reduction is the what? Addition of what? Electropositive elements or group, while oxidation is the removal of the negative guy. So that's to tell you that in this case, you already know that when there's removal or addition of a negative group is already a redox reaction. So this one is a redox reaction. Tick. Now option C, you see that in this case, hydrogen was on its own, but in that side, to when it formed water, it gave out a lost electron. All right, hydrogen undergo what? Reduction. Sorry, hydrogen undergo oxidation, loss of electron. You understand? So it was reduced during the process. So because of that, this is a redox. This is a redox reaction too. All right. So this is a redox reaction. Then this other one too, same thing here. All right. We already know this is already. If you should look at it very well, this is already a redox reaction. So the only one that is not a redox reaction is this. In fact, without me explaining further, from the option B, you're supposed to know that this is not even a reduction or oxidation reaction. Why? Because you can see this guy is a big compound which splitted into this one. So this kind of compound is said to be what? A thermal decomposition reaction. Why? Because for child carbonates needs heat. So thermal decomposition reaction, this is decomposition reaction. The rest are what? Redox reaction. So the only one that is not a redox reaction is what? B. Alright, is B. Take note of that. Alright. Then now, okay, then we'll continue tomorrow. Alright. Alright, so one to wrap it up for today. Alright, so this is last question. Last one says, this is it. This is 3CO2, right, plus 2 ammonia to give us what? N2 plus what? 6HCl. It asks us ammonia acts as option A, an oxidizing agent, option B, a reducing agent, option C, a catalyst, option D, an acid. Firstly, this is already reduction reaction. So, like, there's all that I used to tell students that there's all about elimination method. There's two that can never be the answer. First of all, they are picking C and D. That means something is not right. Something is not right. So you cannot put C and D. There's no catalyst. There's no acid here. There's no acid here. Okay. So now ammonia acts as. Now let's look at something. Okay. So now take notes. There's something I want to talk about for oxidizing and reducing agents. Right. For your oxidizing agent, take note, your oxidizing agent is the element or the group in a redox reaction that accepts electron. Take note of that. Oxidizing agent accepts electron. And the oxidizing agent undergoes what? Reduction. Take note of it. Why? Because according to electron transfer, you can define redox. Alright, electron transfer, you can define redox to be what? The was gain of electron, and you can define oxidation to be the what? Loss of electron. Do you understand? And you can define in terms of electron transfer the aspect in the aspect of electron transfer. Reduction is for gain of electron, oxidation is the loss of electron. Alright. Oxidizing agent accepts is the one that gain electron, that accepts electron. So because of that one, the oxidizing agent is one that accepts electron in a redox reaction. And so I can now say the oxidizing agent is what reduced. Why? It undergoes reduction because why? According to electron transfer, reduction is the gain of what? Electron. Why the reducing agent loses electron is the one that donates or loses electron. And therefore I can say that the reducing agent is what? Oxidized. Why? Because according to our electron transfer, oxidation is what? Loss of electron. So now let's see. Now let's imagine. So ammonia here, all right? Ammonia here was it gained ammonia. You know when nitrogen combines with hydrogen, nitrogen is actually -3. On its valency is -3, so it needs 3. And hydrogen, 3 hydrogen comes to give it this way to form ammonia, NH3. Alright, 3 hydrogen combines with 1 nitrogen to form ammonia. So it's balanced here. Alright, so we have 2. Alright, so here nitrogen is what? -6, and here oxygen is what? +6 to balance it. So nitrogen here was actually what? An acceptor. Okay, was actually an acceptor, right? Then chlorine on the other hand was in its free state, all right? Was in its free state. This should be HCl, all right? Chlorine on the other hand was in its free state, all right? Since it was in its free state, now so the ammonia on this other hand, from ammonia that is from nitrogen here was having 6 extra electrons, but in this place it has lost its electron, so it needs 6 back to be balanced. So because of that one, because from this place to this place, it was actually lost electron. And remember, loss of electron is what? Oxidation. And the oxidizing agent is what? Reduced. Alright, the oxidizing agent is reduced. And remember I said the oxidizing agent is reduced, yes, and the oxidizing agent, okay, yes, okay, the oxidizing agent is reduced, it gains electron, right? But the oxidizing agent is one that accepts electron, okay? Why the reducing agent is one that donates electron. So actually, this guy is oxidized. Nitrogen, nitrogen there, nitrogen ammonia loses its electron. So from this place to this place, all right, according to electron transfer, okay, let me clear it right well. From this place to this place, according to electron transfer from ammonia to nitrogen, there is actually what? Loss of electron, oxidation, oxidation occurs. So since it's oxidized, this is now the reducing agent, right? Ammonia is reducing it because I said now there's a shortcut for easy access. The reducing agent is what? Oxidized. Just know that. Alright, so reducing agents always undergo what? Oxidation. Why? Because reducing agents one that donate electron. If you notice here, nitrogen was having 6 electron, but in this place he needs 6 electron. Alright, how did he need 6 electron? Because he lost hydrogen, his partner that was giving him that 6 electron. And who did he lose it to? He lost it to chlorine in the product side. So because he lost it to chlorine in the product side, that means you cannot see that okay, yes, he lost it to what? To chlorine in the product side. That means he's actually now the reducing agent because it's the one donating, it's the one losing electrons. So it's the reducing agent. And remember, the reducing agent undergoes oxidation according to electron transfer. Alright. Then because we already know the reducing agent is this, our oxidizing agent automatically was chlorine. I use oxidizing agent because chlorine here was -6. But in this it has gained 6 electrons. Remember I said the oxidizing agent is now accept or gain electron. And the oxidizing agent was undergoes reduction, all right? Because reduction according to electron transfer is the gain of what? Electron. So from here to this place, right? Right. From here to this place is what? Reduction. Reduction occurs here. From chlorine to hydrochloride in the product side is what? Reduction. And chlorine is now the oxidizing agent. So therefore, ammonia here is acting as what? Reducing agent. Which option is that? Okay. Option B. So option A said oxidizing agent, and option B said reducing agent. So the answer is what? So the answer is what? Option B. Take note of that. Alright, take note of that. So that is for that. So but tonight I think let me see, what's the time? 10:53. All right. So for now, we are going to call it a wrap for tonight. Okay. So, but tomorrow, I'm really sorry about the whole show. I will keep improving every day. Okay. I promise to keep improving. So tomorrow is going to be better than this. All right. Tomorrow is going to be better than this. First of all, I skipped a very careful because of calculator issues, and also from our other earlier topic, we're having issues with calculation because normally you want to use chemistry, you have to have a very fast calculator. Yes, because we don't know what to be using our head. All right, so that's for that. So we'll look at from tomorrow. I'll work on the calculator, and I will the empirical formula that I skipped earlier. I'll treat it tomorrow. Then I also like treat the remaining organic nomenclature. Then let's see how we can also add letters to what we are doing tomorrow. Okay, so sorry for the delay and sorry for the breaking transmissions. Alright, so but tomorrow is going to be better. See you guys same channel, this same channel. Please, I beg of you, alright. Your subscription is needed, alright. So just tap the subscription button. You can also like and follow. And you can also check the channel and see my TikTok link, the link to my TikTok channel. Just go there. You can also observe it then, like, follow, and share. All right. So invite your friends to tomorrow's class on live. I promise it's going to be better than this, of course, because there was a bit of technical issues and all that. So see you guys same station tomorrow by 8:30. So we're ending right now. Cheers, guys. Signing out. Uh-uh.